So it turns out databases are hard. I don't mean like spinning up a SQL DB and querying it. That part's pretty easy. What I mean is building a really strong, cohesive data model for an application that's changing quickly and is growing even quicker. I have had a crazy experience building T3 Chat, and I want to share some of the things I've learned and, more importantly, the mistakes I've made throughout, because it's been a wild ride, and I want to take the opportunity to share some of what I've learned with y'all. So without further ado, let's dive right into the utter chaos I've put myself through with databases. And yes, I have actually switched databases effectively 3 times in the last 24 hours. I'm really happy with where we landed, but the process to get there was worth a video. I want to dive right in because there's so much fun around our data model, from the local side to the server side to the crazy sync layer that we've built between the two. Before we can go too deep there, got to make sure my team gets paid. So a quick word from today's sponsor, and then we'll get straight to it. Building a web app is easier than ever. Building it safely, a little bit less so. Auth might be easier to set up than it used to be, but doing it right, maintaining it, and integrating all the things you might need, it's never been more annoying. You can check out my 1.5 hour long video breaking down all the different auth options, or you can go with the one that I recommend at the end of it, the thing I use for auth in pretty much every product I build, Clerk. These guys make auth so much easier than it ever was before. I've never enjoyed setting up auth this much, and every time I roll something else, I end up regretting it. They handle everything. When they call themselves the most comprehensive, they mean it. Crazy things that are super annoying to do, like, I don't know, dev preview environments that you can sign into. We still don't have those working on our products that aren't using Clerk, but if you are, it just works. You don't set anything up. It's so much easier. It is not just the server side and sign-in thing they're handling. Obviously, they provide sign-in components, which are pretty cool, but the user profile and user button components, super underrated. You know that fancy little button that appears in the corner of most websites with your profile picture, and you click it and get more info, sign out and all that? Not fun to build. I am one of the many people that's built that many times. Not when I'm using Clerk, though. They just give it to you. You click the button, you get all the info. They even added account switching recently. So if you want your users to be able to switch between accounts, they got you covered. If you want your users to be able to spin up organizations, they got you covered. If you had to deal with some weird MFA SSO crap for SOC 2 compliance, they have you covered. If you don't know what any of those terms mean, they definitely have you covered. And I understand if you're scared about price. I promise you probably don't need to be. It's free for up to 10,000 users, and that's not somebody who signs in once and disappears. They actually only count a user if they've returned to your app over 24 hours after signing up. So you don't have to worry about a viral day where everyone churns, causing you a huge amount of money lost. Clerk's the only auth provider I've never regretted using, and I promise you won't either. Give them a shot today at soydev.link/clerk. Make sure to tell them that Theo sent you. This is the file that powers the vast majority of your experience with T3 Chat. This is my local DB Dexy file. Wait, that's in front end. Why is that the database? Isn't a database supposed to be on the back end? Kind of. You need to hear me out, okay? Generally speaking, when building an app, I don't recommend putting everything on the client. I actually think we've gone too far on the client, especially with tools like React, where we're putting everything in the browser and not letting the server do almost any of the work. That was an overcorrection. There are a lot of things that benefit from being on client. There's a lot of things that benefit from being on server. That said, when I used other AI chat apps, I felt like they did way too much on the server, and also, funny enough, way too much on the client, and the result was a terrible experience. Like if I just go to chatgpt.com and we ignore the insane amount of pop-in that just happened, I can click any one of these. It takes a good time to load. Click around. We're waiting for a while when we switch things. Sometimes the scroll will just break and go up, down randomly. It's an experience, to say the least. It's an interesting one, but it mostly kind of works-ish. When you make a new chat, things all flood around. But the most important detail exists, as always, in the network tab. If we open up the network tab and I scroll the sidebar, we get a loading spinner. That loading spinner can take up to 7 seconds before it resolves, because it is fetching more convos as we get to the bottom of the list, because these conversations live on a server somewhere, and we can look through here to see all of the data for these different items. 3-bit computer solution, created at, updated at, all these other values that aren't being used for anything. And you get a new set of these whenever you scroll. And now if I refresh, you'll have to wait for it to all appear again. Scroll, wait again, scroll, wait again. My favorite thing though, watch this sidebar closely when I refresh. you see how many times things came in and how many random pop-ins occurred over there? We get the first pieces, then Sora and Explorer appear, then Dolly reappears in the middle. Then we get the conversation starting to flow in after. It's just like so many different states. There's like 5 or 6 different states that happen in that sidebar. I'm not going to pretend we're perfect here, but that's a hell of a lot better. And the reason is there is no network request to be looking at. I'm going to switch over to Vivaldi so I have dev tools that are actually competent. Sorry, Firefox and Zen. It's nothing against Zen. It's everything against Firefox. Now when I scroll here, nothing. I just nuked my chats recently, so I don't have as much. But even if I had a ton, it does virtualize the list on client. These events are just generic post-hog events that are being more aggressive than they should. I'll probably go nerf those later because they're annoying. But that's it. There aren't events firing. There's no data being fetched. When I open up a chat, it fires an event, and it's checked by rate limit, so I know if I could send or not. But the data's already there. These navigations are sending events because my URL changed, but there is no data being fetched. Everything is immediate because everything exists here on the client that I am using. And you can see that because I actually let you access it in the console. I made our database, DXDB, accessible. So we can do threads.toArray. We have to assign this to something. Const threads equals await. And right there, is it not? Oh, I spelt threads wrong. Code is hard, okay, guys? Const threads equals await. Now, threads is my array of all my threads. You might notice there's a lot more threads here than I have, though. I only have however many is there. And here is quite a bit more. Here is where the complications start. Because sadly, a thread can't just be the thing with the title. Because what happens when you delete? The sad reality is, in order to make a sync layer that works with this local stuff, you have to not do real deletions. We'll get a bit more into what I mean in a bit. But for now, you see here, status deleted. When you delete something, I have to wipe its contents and mark it as deleted rather than actually deleting it. Keep that in mind. Regardless, you can see all of the data here. You can even go into application IndexedDB, which is a fun web standard for having data in the browser, and see all of the key values for all of the things that exist here. You have messages, projects, search tokens, and threads. These are all the key primitives to powering T3 chat. But what happens when I sign out? Now I'm signed out. If we go back here and we look, we're like, oh, now it actually only has a couple things. We have the thread for onboarding. We have the messages that are in the onboarding. These are messages. This is the thread ID bindings. These are all just like indexes effectively. And here we have welcome, what is T3 chat, when it was created, the response. T3 chat is the best AI chat ever. You get the idea. It's all the content that is on this page. So what happens when I sign in? How do I get my chat back? Well, I'm going to hide my sign in so you guys don't get my email, but I am going to show the network tab when it's done. Cool. Now we're signing in. We came in pretty quick because right over here, we'll see this sync event. Sync is a request that you make authenticated over to the server that will get all the data we need to sync. And when you get it, it responds with all of that data. And it's not a little. Here it's 90 kilobytes. For some users, it's going to be a hell of a lot more. But that is the data that we have stored as our effective backup that we use to keep track of your state. But that's the only point where we pull it down. We will again on refresh. But now you have the whole world, so to speak, your entire history built into your local environment. And now when I click things, I don't have to wait for the server. I could even turn off the web side of my browser. I could turn off networking entirely, and I can still navigate fully. And I think that is awesome. I think it's really, really cool that you can make a tool that uses all local data and doesn't require a network round trip ever to navigate and find things. Hell, even search works fully offline because of this model. So where are all these database changes I'm talking about? Well, it's time to get into Excalibur because there are 2 sides where the database has changed. Because remember, we effectively have 2 databases. We have to have the local solution, which is the in-browser thing that keeps track of all your data. And we have to have the server solution, where we actually sync and back up that data so we can restore it when you sign in and out, so you can have multiple devices, all the things people expect from their experience. And believe me, I wish I could pretend the server side doesn't exist right now more than ever. As the server-leaning React dev, I've been to hell and back with this app. So let's talk about this local side first, because I wanted to be sure when I built this that we nailed that part, because it's the key to our app. Most apps don't need to have all the data locally, but ones that you use a lot, that you keep open in the background, that you search through, that you check, things that you spend a lot of time in, benefit greatly from it. And I was spending enough time in these AI chat apps that I wanted to make something local, because I was tired of the weird chaos of the ChatGPT and Claude experiences. They're rough. So what do we do here? Well, our first exploration actually kind of tried to solve both. Zero. I'm putting it under both because these were tied together. Zero is built by the same people as Replicache. Replicache is the somewhat, I guess industry standard's a fair thing to call it. They're the go-to, been around for a while, real-time sync engine for having your backend and your front end have the exact same data. So you don't need to wait on the network to get the data. Once you have it, you can do things and it will sync up the changes and it'll sync down things that happen in other places. You'll also notice when we look at these local first tools, real-time and collaborative tend to be other things they mention. Local first rarely actually means just local first. Often when they call things local first, they're implying real-time and collaboration, which are not local first. These are two different, distinct things. And I wish they wouldn't always group them in, because that's been a consistent problem. I'll even make a note that there are 3 specs that a lot of these go for. 1 is local first, 2 is real-time sync, and 3 is collaboration. So our first exploration was Zero. Zero is a new product from Replicate with the goal of simplifying local sync with a Postgres server. They're building a general purpose sync engine for the web. You put Zero in front of your DB or web service, and we distribute the backend all the way to the main thread of the UI. You get a client-side API that looks like an embedded DB, but it can arbitrarily do hybrid queries that span the entire database, including the server. So you'd write on the React client side, zero.query.playlist in their use query wrapper, .related tracks, related albums, related artists, order by play count, where ID is ID. And this will use the data that's already been synced locally to do this query. Now you don't have to wait all the time to get things like tracks. It seems so promising. I do still think Zero has an incredibly good chance of being one of the solutions people reach to, but it has its problems. The big one that I ran into in my mental model for it as I tried is that you are effectively required to split brain your data really hard. So this is their example. And in here, we have our source for our main app. In here, we use query, z.query.user, z.query.medium. All this code looks really good, nice and simple, and makes a lot of sense. Even the updaters are pretty cool. z.mutate.message.insert, random message, users, mediums. Now I put something else here, like an array with the wrong type. It's even smart enough to give me a type error saying, hey, that's wrong. You need to put the right type of things here. It has to have ID, name, and partner. If you give this 57, now that's wrong because it has to be a Boolean. Cool. That all makes a lot of sense, and it's cool to see full stack type safety from our query layer, our mutation layer, all that. But then you see how we got that. So we have our schema here that we've defined. Actually looks relatively similar to something like Drizzle. The problem is this is not the only place where we have to define this. Hop over to Docker, and we have to also define the same shape in our database with SQL. This isn't generated, this is handwritten. This one's a seed that has all of these default values for playing with it. Cool. We have to make sure the relationship here matches. And in the schema, we have to write out a permissions model to determine what permissions things do and don't have. It is not simple. It's not the worst, but you do have to define all of this yourself. All of your relations between things. Good luck doing migrations where you have to make a migration in SQL and make sure it perfectly matches the code here. Good luck making sure users are on the right version to make sure this all comes together. Hell, when you do bump your version for Zero, they have a section in here about upgrades somewhere. Okay, this is new. When we were trying to deploy it, they called out that there was no way to do downtime-free updates. If you were to update your Zero deployment, some user could potentially hit an error because the service wasn't up. And that sucked. There was no way to upgrade or change things without forced downtime, so to speak. Yeah, not fun. I'm happy that it's getting better. But my biggest concern isn't even any of this. It isn't even the fact that it's so alpha, it's still relatively immature. My biggest concern is that it's not open source for shit. We can go to the GitHub, and the GitHub is just the Hello Zero template. None of the Zero stuff is actually open source. They have examples of their clone of Linear and their clone of Excalidraw built using Replicate and built using Zero. But even this repo is closed source. It's just a README file. I wanted to be sure that if I had problems with the tech I was using, that I could fix them. Because I have been to hell and back with tech that I couldn't fix, and it made me really frustrated. And I am deep enough in the things I use now to be able to fix the problems I run into most of the time. Famous last words. But these were the things that led me away from Rocky Corp. Just because Zero felt really new, it felt really early, and it felt like if I ran into a problem, I'd be stuck waiting for them to fix it, and I didn't like any of those dynamics. Looks like I was actually wrong about Zero. It's just part of their mono repo. I don't know how much of it is in here. I know that a lot of their core like sync layer isn't open source. I know that for a fact. But this is more open than I thought it was. Good to know. Misconception. I will take some blame for not knowing that Zero had open source parts. I'll put more blame on them for not making that information a little more accessible. That's Apache license. Cool. Did not know that. Lesson learned. I will investigate more to see how much of what I care about isn't actually in here. Tier client zero cache, ZQL. Oh, it uses Replicache under the hood. In the Replicache client library, oh, it is actually open source. I didn't know that this part was open. I've actually been told by people using it that this part wasn't open. So I'm not the only one who's misled on this. Thank you, chat, for finding this link. So I wanted something that went as far the opposite direction as possible. I wanted something where none of this was true. I wanted something open source, something far from early, and something that would let us mangle the data model for a bit until we got it just right. I hunted for a while and made an interesting discovery. Dexy, minimalist wrapper for IndexedDB. Holy hell, has this library made my life easier. Dexy is a really minimal, relatively old library for doing IndexedDB stuff. IndexedDB is not something you want to work with directly. I could do 2 videos describing how rough the IndexedDB APIs are. I will politely ask you to trust me on this because it is bad. Dexy has been around since like 2012 or 2013 because of how bad IndexedDB was. There are pages in these docs that talk about certain regressions and features that exist because of Internet Explorer 8 support. This is an old library, and it's still being maintained pretty well. And it even has fun bindings for modern things like Vue and Svelte. And obviously the thing we care about here, React. Dexy is relatively simple. It's weird to wrap your head around because of how flexible the model is, but once you're used to it, it makes sense. The important thing to know is that IndexedDB isn't a relational data model. It isn't like SQL at all. It is just a KV store. All IndexedDB is a KV that can have a lot more values and a vague concept of tables. Dexy makes it a lot more flexible by letting you define what shape data should be in, define different indexes so you can look things up by different values. It solves a lot of the problems that are inherent to IndexedDB, the world's most unnecessarily complex KV. So here's a simple Dexy example. We make a new DB, we define version 1, and this is also how you bump versions, we'll probably get back to that in a bit, and it stores friends, which has ID, name, and age. It's worth noting that this isn't the shape that the data has to be in. You can pass things that aren't in here as part of the value in that KV pair. This is just what it indexes on. So when you put things here, it can look up with those faster, but you can put anything in the store once a table is defined. So here we have friend with TypeScript, has an ID, a name, and age. DB has our friends, which is an entity table with friend. We indicate the primary key of ID. Then we have our store. Friends has ID, name, and age. And now we have access to all these things. Cool. Awesome. Making a lot of progress here. But where it gets really cool is once you actually start using it in your app. If you want your component to query data, use live query. And this is where it gets magic. When you call some data, so in here we're listing all friends as an array, you get the value. It's null initially because it's all async and fun. But now, when any friend changes, this component gets updated and reruns. Super cool. Fun fact, the entirety of the live chat updating. So the chat getting new tokens in T3 chat as new like content streams in. I'm literally just appending the content to the message field from the message table. And that forces the component to re-render. I didn't write a custom render loop for that. I went out of my way to memorize the shit out of everything around it. But the model here lets me just instantly update the thing right when it changes. You need to be careful about what you're selecting though, because if I selected all messages or even touch messages in a query too high up the tree, then every single token streaming in is going to re-render the whole app. And that's why we've had to put a ton of time into things like memoization and using React Scan to make sure re-renders aren't happening when they shouldn't. And the result is that it runs really, really well. But God, Dexy has been awesome and solved so many problems. But Dexy's also caused a few problems. Remember that thing I said earlier about wanting open source stuff? My one gripe with Dexy is that they have a cloud product, but it is a closed source cloud product. It is a cloud product that has a weird payment model. The free edition lets you have up to 3 users and 100 megs of storage. The production version is 12 cents per user per month, which with our 300,000-ish users would bankrupt us. But they also give you an on-prem option. You can pay $3,500 to host it in your own server, or you can pay them $8,000 to get the source code. It's just weird. The problem here is none of these options give me a good idea of what performance characteristics look like at the scale that we're shipping. And they're also really focused on specific stuff around live syncing, updating, and most importantly, WebSockets, which comes up a lot. So when I needed a place to store the data, I was not so sure about Dexy Cloud yet. So I solved the problem. When we picked Dexy for our local layer, I needed somewhere to put that data. And I picked an interesting place. We'll call this Redis V1. V0 is probably fairer. The way sync originally worked with T3 chat is something that you guys should probably make fun of me for. But at the same time, it worked way better than I expected for way longer than I expected. The way sync originally worked, I'm going to actually pull up the GitHub repo and find it because it's really funny. The way the sync worked is we would take all of your messages and all of your threads, super JSON them, and call my sync JSON to DB function. And the way we handled this is I would create a text encoder, take that JSON string, gzip it, and then post it up to the sync endpoint. Your sync, your store, your backup was the entire contents of your database, super JSON, so I wouldn't lose date times, gzipped, and thrown up to a KV where the key is your username or user ID and the value is your gzip blob. And to sync, I would do the opposite. I would bulk put. So it would update if it was more recent than what content you had locally, and it would add if it didn't already exist locally. And this worked surprisingly well. I was amazed how long this actually worked for. This was the model up until 4-ish, 2-ish days ago, honestly. It worked great. And from my testing, I had a demo. I added utils for testing like a lot of threads and a lot of messages. I had 1,000 threads with 2 messages each. And the size of that blob once gzipped was only like 200 kilobytes. It seemed totally reasonable for this to be the path for a while. Then people started posting 100,000 word messages. They would just go copy the docs for something they were in and paste the whole thing as a message and hit send. And now from like 3 to 4 messages, they were nearing 800 kilobytes. There were a couple users hitting like 2 to 3 megs after gzip. That was breaking everything. It was breaking everything quite quickly, actually. And I realized over time, despite my best efforts to handle breaking that up, that this wasn't viable anymore. And I decided it was time for Redis V1. Actually, we didn't get there just yet, because I spent a lot of time thinking at this point, trying to figure out how do I get myself out of this terrible hole I've dug. I looked into Dexy Cloud. I started talking with the Dexy team more. I explored further to other local first things. The first I looked into was one named Tinybase. I actually found this from, of all places, the Expo documentation. This one looked really cool. It's open source, it's reactive, database-like, and it syncs. And it's built for local first web. Okay, cool. It's checking all my boxes so far. Supports a ton of different things, which is really, really cool. It looked more and more like Tinybase was going to be the move. But I kept digging, and what I ended up finding was a pretty consistent use of the term WebSockets. The expectation was clear. TinyBase's sync layer has two options. Option 1, you do it through a WebSocket. Option 2, you do it your fucking self. I was not happy with those options. There was one other I forgot to mention earlier. This is one that I actually explored before committing fully to Dexy. In fact, pre-release, I spent the night before launch trying my best to rebuild the entirety of T3 chat with Jazz, because a few people I really trusted recommended it. There's a lot of cool things in Jazz. Here is a chat app built using Jazz. We have our iframe hash router, terrifying. Our chat creation, on chat load, chat, cool, fun. You'll see all of these group and chat calls coming from the schema global. And we render the chat screen if we're on the right page for it. So let's look at the chat screen here. Use co-state, chat, props.chatid. And now we have the chats here. Cool, awesome. So what's my problem with this? Why did I not go with it? The co-model is so painful. The expectation is you have one global object, usually the user's identifier object, and then it has children for everything else, which straight up does not work for us because we have a signed out state. The reality is that Jazz was just not even kind of prepared for a signed out experience. And I talked with the team. They worked really hard. The Jazz team clearly cares almost maybe too much about making Jazz a great solution. One of the best experiences I've had working with open source devs on a short notice. It was not ready for us. It did not have an even vaguely happy path for a signed out experience. And rather than hack one in, which we tried hard to hack one in, I ended up rage quitting and moving back to Dexy. So we went from 0 to Dexy to failing to set up Jazz, back to Dexy, to exploring TinyBase, realizing that I did not want to deal with WebSockets and building that sync engine myself, and that the effort to do it would be as great as fixing my work on Dexy. But I wasn't done hunting. Legend State is a really, really cool state management solution. This comes more so from the React Native world. The creator of Legend, Jay, is just as well known for his list component for React Native as he is for state management stuff. This is a really good, really fast library. It's super focused on React. So if your goal is something that is super React-y and super React built, this is there for that. You create your state as an observable. You can set it outside of React, and you can call it with the use $sign inside of React. There were a couple rough edges here and there, especially because there were recent changes with the v3 to make it more React compiler ready that resulted in syntax changes that were unintuitive and the docs were not properly indicating them yet. But Jay was also a bro, super fun to work with, gave me a ton of insight on all of this. I got a prototype working with Legend, and our conclusion was that I should probably just go roll it myself anyways, because the sync side here was either really hand-holdy with their Keel and their Supabase plugins, or it was very rough and waiting for you to do the work with the CRUD build. And as I read through the CRUD plugin and talked with him and kept figuring this out, a couple things came to mind and a couple realizations hit. Specifically, all the hacks that I was trying to avoid, things like soft delete, were things for all of these sync engines. And when I realized every option requires the same workarounds, I couldn't find a solution to the workarounds. I had to just work around them. And I got told by both the creator of TinyBase as well as hinted at by the creator of Legend that my needs were both simple enough and specific enough that I would be better off building it myself. I want to do a quick tangent about the local soft delete thing because it is unintuitive. Let's say I have two computers. They're both signed into T3 chat. I have multiple threads. We'll call them thread 1, thread 2, thread 3. These threads exist on both devices. I also have a database somewhere that's storing this data. So now, whenever one of these clients opens, it's going to pull all of the data, and it's also going to sync it up. So whenever a change happens, like I send a message, I would sync up the whole of the data. So if I add a thread 4 here, when I submit it, it gets added up here. So now the database has thread 4. And eventually, whenever I open this client again, it's going to pull down the new update and have thread 4 added. What happens if I delete thread 3? Well, if I delete thread 3, it gets removed here. Now the client here pulls down. Okay, cool. It doesn't have any new data to pull down because there's no threads here that aren't already here. But then when it syncs up, it's going to sync thread 3 back up. And now that thread you just deleted, it's back. Hope you didn't want that deletion to be forever. Not fun. And the only way to fix this is to never actually delete the thread. Instead of it being thread 3, you'd put something like this in that index. And now, when that sync comes over, it gets replaced with deleted because you have obviously some ID indicating what that is. But that's what a soft delete is. Instead of removing it from database, you take that ID, you null all its values, and you give it a status deleted so that you know on other things that have their own partial states what you actually intend, which is for the thing to be fucking gone. So you have to do that. And there's a lot of these other small things you're going to have to figure out if you're building a local first model. Not fun, but you get the idea. So I did all of this. The problem was that diffing each of these sucked, especially when you had these giant tables full of lots of things. If you had 10,000 messages, no one has that many, but there's people with over 1,000 messages. If you had 1,000 messages, whenever you load the page, you have to pull all of them down. Not viable. It also means I can't just constantly be pulling more. We've already had like 400 gigs of traffic on T3 chat because these 2 to 3 megabyte payloads are big enough to rack our bill up over time. So I need a way to do this more granular. We can't store the whole thing as a blob. That was kind of a hack when I started. It's a hack that went way further than I ever expected it to. I'm thankful we did it. We would not have been able to ship so fast and make so many changes without that hack at the start. But it was time to explore other things. As I said, we tried out Jazz, gave up, tried out Tinybase. I'll admit, I never knitted the Tinybase code base. I just dug through docs and stuff. Was impressed, and there's a lot of places I think Tinybase makes a ton of sense. Not here. The one I was closest to pulling the trigger on was Legend. It was really close. But honestly, the best value I got from Legend was talking to Jay and learning how all the parts in Legend come together to better mentally model how to do this right myself. And what we ended up landing on was Dexy, but a full overhaul of the data layer with what I call now the V1 of the Redis implementation. The V1 of the Redis implementation was a pretty sizable change. Instead of it having one blob per user, each message in each thread now has its own KV. Redo sync layer with messages and thread tables. What a PR. I called it sync v4 because I had lost track of how many times I rewrote it, and 4 felt like a big enough number. In here, we made some significant changes. Now on the server, I rewrote the get route, and honestly, I should probably just pull up what this was at the time. Here we are. All using Next API routes. Get would check auth. I would call this get all threads for user and get all messages for user. Stringify the results, return as JSON. Post, a little more complex, but same deal. I'd grab all the threads that you posted up and all the messages you posted up. I'd go through each of them, make sure they're not too big, and then promise I'll sync them. Let me go look at the actual sync part in here. Here we are, the sync Redis DB. Of course, that doesn't open a new tab. Why the fuck would it? Cool. So now we have a separate key for your message and a separate key for your threads. And sync messages would create a KV map for all of the messages to create the key for it and map the value. And I would call mset with this map to update all the values with whatever the hell you just sent. This ended up not working and I had to chunk it. I'm not going to even bother showing that PR. It was fun last minute changes. Also notice the key is user ID : sanitized thread ID. That's important because the IDs are all defined on the client side. So I had to make sure that you couldn't override someone else's thread. Like if you saw me in T3 chat and you saw the URL for my chat was, I don't know, this here, that's the ID for this thread. So if you knew what the ID was, you'd be able to override that. I could build a crazy permissions model or some shit. But why would I build something smart when I can build something clever? And my much more clever solution here was to have the first half of the key here be your user ID. So now you can't do anything to my shit. A+, works great. The key namespace was a phenomenal place to solve this. Thank you, chat, for not calling me stupid for doing it. And this actually worked pretty well. We had our key generator to make sure the keys were user specific. We had a function to sync all the messages, a function to sync all the threads, and then a getter to do the same thing the other direction. The client side barely changed. Actually, I don't think it changed in this PR at all. All it was the server side. Wait, no, I stopped gzipping, so the client did change a little bit. But the endpoint I was hitting would just take the JSON, super JSON blob of all your data and now go store that in the KV. And here is where things started to fall apart. This is the production deployment on Upstash. Very happy with Upstash. Phenomenal provider, making my life significantly easier. You'll notice something interesting happened a few days ago. We went from storing about a gig of data to a lot more very quickly. We also started transferring significantly more data too. I don't think they have a graphic for that, but over the first 3 weeks of T3 chat, we did about 70 gigs of bandwidth. In a day after this change, we'd done another 40. Not great. And the performance, especially after I handled the chunking and the pagination, started getting pretty slow. Generally speaking, Redis as an in-memory store is strongest when the amount of data it's storing is small and the overall key space it's storing is smaller. And if you look at the number of keys we had, you'll see the scariest number. We went from 1 key per signed in user who had a chat sync to 1 key per thread and message. And in the course of a few hours, we went from 50,000-ish keys to almost 1 million. Thankfully, it still worked. I was surprised. The edges that it hit were mostly fixable. It was all just chunking the updates and chunking the fetch parts. But not the right thing to use Redis for. If you need to select thousands of keys at a time, Redis is not the right place. And I'll be honest, yeah, sure, should have known this. And it's not like I didn't know this. I just wanted to see how it would perform and what this would look like. And when I did the first pass on it, even with my huge testing data, it went pretty well. If you didn't know this, one of the cool things that we built in early on T3 chat is a message history import and export. So you can export your messages. Some of our users were generous enough that had huge histories to export them and send them to us to use for testing. So I had actual real world giant histories to test with. And I realized quickly that the model I had picked here was not going to work particularly well if I kept it on Redis, because the sheer number of messages some of those users had was terrifying to me. So how do I fix this? We have effectively concluded Dexy is fine. We've also effectively concluded that the model on the client side is actually working quite well at this point. The problem is Redis is not built for fetching 1 million things at a time. It is built for fetching a small number of things really, really quickly. There is something built for doing a lot of data at a time. Something I've used a lot in the past. Something I missed dearly. PlanetScale. PlanetScale is an old sponsor of the channel. They no longer are. They haven't paid me in a very long time. I do technically have a little bit of equity in them. I don't even know how much. I haven't bothered checking in a while. They don't know what their exit plan is, so I doubt I'll ever get anything from that. But account for bias accordingly. PlanetScale handles scale very well because they built with Vitess, which is a method of scaling your MySQL database by sharding the absolute shit out of it. Their tech, Vitess, powers a lot of things. PlanetScale itself is powering Barstool. I believe they're also powering Intercom, but their tech, the open source Vitess MySQL scaling solution, powers Slack, partially powers GitHub. It was originally built to power YouTube. It's really good tech. And I know that because as soon as I spun it up, life's been good. We're doing comical amounts of traffic in this now. It's still a relatively small number of queries per second, but the amount of rows being selected per second is kind of insane because people are pulling their data and the amount of data it's pulling is crazy, especially for some of those big users pulling 20,000 rows on page load. It's nuts. So when I moved over to this for our data, I wasn't sure how the performance characteristics would be because it's very read heavy, not particularly write heavy. But holy hell, has it scaled great for us. Our row reads since deploying have been minimum 9 rows a second up to 200. It's also all on the $30 a month base tier for PlanetScale, by the way. Not upping it at all. It's just handling this all fine. Our IO is not hitting limits at all. We are fully within what this cluster is configured for. Do they show CPU limitations in here anymore? You would know if your P95 and 99 started getting bad, but our P50 is 7 milliseconds, our P95 is under 50. It's great. And if I click here, you can see when I deployed. Also, the crazy stuff I was testing early on for figuring out what the migration story would look like. But you can see the moment we went live, and we've just been consistently getting a ton of traffic since, and it's fine. It just doesn't really care. It's been really nice to use it again. But this must have been a terrifying migration, right? Like moving over from a KV to SQL. Well, the fun thing about a KV is that basically anything can become a KV with enough effort. If we hop over to my actual deployed code base right now, the DB tab, we have the old KV because we're still using this for restoring old data. We're also still using KV heavily for rate limiting. It's very, 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 very good for that use case. But our actual database is now in this new SQL folder. Here is our real DB, named to make sure it's clear in the code base. Here's our schema. Message table. Has an ID, has a user provided ID, and then a user ID directly. The ID is something we assign so that we can make sure all the diffing and indexing is handled properly. User provided ID is the key that we had before, where it'll be user ID : thread. And the user ID is your actual user ID, just so I can index it and grab all your things very quickly. But then we have our data type. I am so sorry. You have no idea how much easier this has made our lives. It's great. And as long as we make sure we're not putting big things in it, it's fine. In the future, we won't be doing this. But for now, as our data model continues to shift constantly, we'll be doing this for a bit. Images are stored on upload thing, dumbasses. Come on, we already built a solution for that. Obvious. You guys know better. And obviously, table is much more complex. And by more complex, I mean the exact same fucking thing with no difference. And here's where it gets real fun. Let's pull up the PR for this quick. Move sync to SQL on planet scale. These diff numbers look scary. Plus 1200 minus 102. If you remove the package lock, this was a plus 200 line change. Drizzle config, nice and boring. Package JSON, nice and boring. PNPM lock, most of the code. Actual code. API, no longer managing the decompression and recompression. I added backfill later. Threads messages is get all threads and messages from DB. Parse threads is me deserializing the super JSON for the threads and the messages all here. If parse threads at length is 0 or messages at length is 0, then I backfill. This is me grabbing from the old KV, so I have your old data, pushing those to those values. I respond with this, but I also wait until on my backfill so that it can keep running in the background without blocking you getting your response. Yeah, we have the wait until here at @vercel/functions. This file got eroded. It's way simpler now. I have my legacy old data solution, because remember, I had two different states of the data in KV. I had the single blob and I had messages and threads. So I had to first check, do you have threads and messages separate? If so, cool, use that. Otherwise, I have to go grab legacy V1 data from prior. Then I have my backfill, where I update the threads and the messages here. I have my backfill promise. I wait until on that so it doesn't block the response going to the user. User gets the response. So the migration story is you open the page. It's great. Who needs a migration when you have users? And if we click the little tab button here, you'll see my favorite fact about this PR. Obviously, we had to change the route a little bit to hit the new functions. We had to change backend to handle deletes a bit different. The front end file was not hit once. Moving us to SQL did not require a single change to the client. The endpoints, as I had defined them, were more than capable. I had fully figured out the model and the relationship between the client and the server at this point. The only problem left was that the server model I chose had quirks and catches on the data storing side that I knew it had. I just didn't expect to hit them as quickly. And by quickly, I mean within 5 minutes of deploying. Problem solved. Really cool that our architecture had solidified to the point where I could yank out the database 12 hours after yanking out the database, and everything was fine. I don't think I've had to make a single change to this since we did it, because it's been so reliable since we shipped it. I had to make a bunch of changes to the Redis version because I needed to handle large numbers of keys. This one just kind of went fine. And to those asking about other databases like Neon and Turso and whatnot, I've used them all in the past. None handle scale well. Some might someday, but I promise you, from my experience on Turso, this would have collapsed Turso. If we had spent the time to do the per user DB model on Turso and worked really closely with them on it, cool, awesome, fine. My experience with Turso has been nowhere near good enough to confidently ship in a service that has hundreds of thousands of users on it. That would be, no. No. I'm tired of the SQLite shitposting. Stop pretending it scales that well. It does not. It certainly doesn't scale well on SQL as a service providers. No. Stop it, please. PlanetScale is the only reasonable option for a SQL as a service that scales to this level. There are other things that are decent, like Single Store. We've worked with them in the past. You'll be seeing them in other videos going forward, I'm sure. Single Store is also a fork wrapper alternative MySQL thing that scales pretty well. God, everyone's suggesting Supabase in chat. I envy your innocence. I genuinely do. I adore it. It's so cute. Supabase is fine and is one of the better Postgres options if you're running traditional servers or you have very small scale. Supabase keels over almost immediately if you have enough lambdas running against it because it has really rough connection limits. And I've worked with companies that have been told by Supabase, you need to stop using Vercel at your scale if you want to use Supabase. And they moved off of Vercel instead of moving off of Supabase. Yeah, no. And God, Vercel Postgres, it's just Neon, right? Right? None of these options are ready. Believe me, I want them to be. I would love for there to be more competitors to PlanetScale simply because I can make a lot more money off sponsors. But I can't confidently, like the only one that I'm confident enough in the scale of to make a regular is Single Store. And they're $50 a month minimum to get started. And they are very focused on things that aren't our TypeScripty world. Just the experience I had with their Drizzle binding is enough for me to say that Single Store is a great all-in-one database platform if it does things you specifically need. PlanetScale is like the Lamborghini of TypeScript dev dream databases. It's so expensive, unnecessarily so, at most scales, but at real scales for real production workloads that are causing Redis to collapse under the raw I/O. PlanetScale is the only database that responds faster than Redis on a serverless environment and scales better than running it yourself in RDS. There's a reason they won. There's a reason they could kill the free tier and make more money as a result. It's because their shit's good, and it's really nice to be home. I missed you, PlanetScale. Thank you for still being you. So where we landed is effectively the exact same Dexy, but with SQL on PlanetScale. And obviously, using Drizzle as well. Works very, very well. Very happy with Drizzle. And this is how I switch databases far too many times in just a few days. So what are my conclusions after this journey? Don't do local first. Seriously, it is not worth it. If being local first isn't a key differentiator for your business, don't fucking do it. You can make an app that is 95+% as fast using really basic cache behaviors and just having routes defined on Next.js with prefetching. You don't need to do any of this. You will regret most of it. Trust me, this is not worth it unless you are an insane person that's goal is to make something 5% better than what is possible without local first. And you can justify the expense by making content about it. Hi, please sub if you haven't yet. This is a lot of work. Yeah. If you take anything from this, it should be that local first tools are focused on the wrong things, do not scale well, do not integrate well, and do not provide a good experience unless you really know what you're doing and you're fully committed to the model. It is easier more often than not to just build it your fucking self. And building it yourself is not easy. To go back to the three things here, local first, real-time, and collaboration, almost everything here, even Dexy Cloud, has kidded itself that local first means all of these things. Local first is a spectrum. On one side of that spectrum, there is T3 chat. On the other side of that spectrum, there is Figma. There are things that are between these that fit in other places, like linear goes here-ish, I would say. The difference being T3 chat doesn't need live updates. It doesn't need a multiplayer experience. I need it to work well signed out, and I don't care what somebody else changes when I'm on the page. Figma has very different needs. Even if I delete T3 chat and put linear here, I think we can all agree that the database needs of a linear and of a Figma couldn't be that much more different. They are very different. And if you pretend that both of these are the same box, that box is called local first, and I'm going to sell you a solution that fixes the problems in this box, I hope you're selling a bridge as well, because this is fucking stupid. This does not work. Everyone pretending that local first is a category they can solve doesn't understand local first apps or the things they're building for. Stop pretending you can solve this problem. Fix it. Don't solve it. Fix the problem for the space in it that you want to solve for, And stop pretending that every app needs this, that every app can use the same solution for it, because the creators of half these solutions admitted to me that their solutions wouldn't work well for me. It's just not fucking reality. And I am tired of being gaslit by this weird local first movement when I've built a bigger local first app than most of them have. And my conclusion is that all of the tools are either wrong or bad or worse. If you can't tell, this one's driven me kind of mad. I've spent the last month and a half now. God, time flies. I've spent way too much time figuring out local first, diving way deeper than any sane person should ever have to. And if you get anything from this video, the thing you get should be that your UI is best driven by the server. Make your servers faster. Don't spend all your time on this shit. That all said, if you are one of the people that really, really wants to do this, Dexy if you care, Jazz if you don't, Zero if you're patient, Legend if you're right, Tiny Base if you want more options. There are a ton of other things that I didn't touch on here that I spent a lot of time exploring, even other companies I invested in, like Electric SQL. Electric SQL is a Postgres sync engine. The people who made it also built PG Lite, which is somewhere in here. PG Lite is open source Postgres in the browser using WASM. Awesome. Really cool. Nowhere near ready for the full stack problem solving space I want to live in. So I guess I'll put one last one on the bottom here. Electric SQL if you just can't give up Postgres. And this all is with the caveat of please don't bother. But if you must, this is where I'm at. Hopefully this is helpful to somebody. I have no idea why you watched a video this long about database technology you shouldn't bother using, but you did. Hopefully it was fun for you. It wasn't fun for me. Okay, that's a lie. It was actually really fun for me. I had a great time. I had a lot of rage-induced nights. Like, I was working on the V1 move until like 6 a.m. that night and just merged it with Mark asleep and went to bed soon after. And it mostly went okay, but yeah, take my madness here as a sign to not do this unless you really, really need to. If seeing all of this hasn't turned you off from local first entirely and you're still convinced it's the right solution to your problem, awesome. Go do it. But if you were already iffy on it and then you watch this whole thing, hopefully now you understand this is not worth doing. And I didn't even mention the fact that the only time our database ever gets updated is when the local instance pushes. When you send a message, we don't write that in DB. That gets written when it's done streaming to your device. So we are actually local first. I could do a whole separate rant about how 50% plus of these technologies aren't actually local first. They're local cached, server first. I'm gonna die. Oh, one last note. If you do think you need local first because you want to have your pages load immediately, you want to have the best possible experience for your users, here's a React query provider. See this? Local storage persister. Everything I call through React query is cached locally. I don't need this for most of what we built. The local data model lets you do updates much more easily, but chances are, if you're building something like this and you really want the fastest possible page load experience, what you want to do is cache your queries and call them earlier, not to locally store everything in a whole different model. And don't get me started on the mobile app. It's going to be a long month. That's all I got. Don't build local first. Peace, nerds.